So now we'll look at the second indeterminate form, which is you have an infinity minus an infinity. All right, all these ones are going to be pretty similar, so we're just going to end up doing one example for this. All right, we're going to evaluate this limit. All right, if I plug in 0, well, the first part I get 1 over 0. 1 divided by a really small number gives me a really big number, so this is going to give me infinity. All right, tangent of 0 equals 0. So again, we get 1 over something that's close to 0. It's going to be a really big number. All right, so I have infinity minus infinity if I tried to plug in 0. All right, the trick here is I'm just going to, right now I have these two different things. I'm just going to combine them. So in the left-hand fraction, I'm going to multiply the top and bottom by tangent. In the right-hand fraction, I'm going to multiply the top and bottom by x squared. And I'm doing that because I'm getting a common denominator. Now I can combine this into tangent of x minus x squared over x squared tangent of x. And now what would happen? All right, this piece here is exactly equal to that. I just combined the fractions. And now what would happen if I plug in 0? On the bottom, I get 0. On the top, I get 0 minus 0. So now this is another L'Hopital's rule problem. And so now if I want to do this limit, I take the derivative of the top and bottom. So the derivative of the top is going to be secant squared of x. That's the derivative of tangent minus 2x. On the bottom, I have to do the product rule because I have x squared times tangent of x. So I'm going to keep the x squared. Derivative of secant squared is, derivative of tangent is secant squared, plus keep the tangent, and the derivative of x squared is 2x. So that's what that gives me. And now I want to try to plug in 0. So I'm going to have secant squared of 0 minus 2 times 0. And it's important here to know, we already know tangent of 0 is 0. Secant is 1 over cosine. All right, so secant of 0 equals 1. All right, so if I plug all that in, I'm going to get a 1 minus a 0 over a 0 minus 0. So this gives me 1 over 0. And here I cannot use L'Hopital's, even though this is a bad thing. I don't want to have a 0 on the bottom of the fraction because I'm not getting 0 on the top of the fraction. I can't use L'Hopital's or go again. I just need to understand what happens if I have a 1 over 0, if I try to plug in this limit. And just remember, if I'm dividing by things that are getting close to 0, that's going to make the numbers get really big. My final answer is going to be infinity. All right, so this whole limit is just equal to infinity. It turns out the first infinity wins, and even though I'm subtracting another infinity, my answer still ends up being a really big number. All right, so when you have these infinity minus infinity examples, pretty much every single time you just combine the fractions, then you probably do L'Hopital's rule and plug in and get your answer.